If the great geological labors of the oceans, such as the erosion of cliffs, the demolition of promontories, and the construction of new shores, astonish the mind of man by their grandeur, on the other hand, the thousand details of the strands and beaches charm by their infinite grace and marvelous variety. This is a quote from Élisée Reclus, The Ocean, Atmosphere and Life. Professor Shepard, 1963, produced a classification in which coasts are divided into primary and secondary coasts. Primary coasts are those that have been shaped primarily by terrestrial agents, including plate tectonics, and are subdivided into land erosion coasts, rias, fjords, etc., subaerial deposition coasts, deltas, and alluvial plains, glacial deposition, and etc., volcanic coasts, and tectonic coasts, faulted and folded coasts. Secondary coasts are those in which wave action and other coastal processes are the dominant control on the form of the coast, and these are subdivided into wave erosion coasts, marine deposition coasts, like barriers, salt marshes, etc., and coasts built by organisms, coral coasts, mangrove coasts. Professor Inman and Professor Nordstrom, 1971, classified coasts related firstly to their continental scales and based on plate tectonics. They divided coasts into three major groups. First group are collision coasts. A. Continental margin, characterized by cliffed shorelines, narrow coastal plains, and deep ocean trenches, with his mountains just inland. Example: Chilean coast, Californian coast. B. Island arc collision coast, which are similar to A in general form, but lack major mountain ranges and large rivers associated with the continental margin. Example: Japanese coast. The second group are trailing edge coasts that can be also subdivided into A. New trailing edge formed near the beginning of plate separation, example, Red Sea, with little or no continental shelf development. B. Afro trailing edge, characterized by hilly or plateau coasts. And C. Emerald trailing edge coasts with wide continental shelf and large rivers draining the inland. Example, Brazilian coast. Third major group are marginal sea coasts, coasts fronting on marginal seas and protected from the open ocean. Example, the Mediterranean coast and the Chinese coast. This map, presented by Professor Inman and Professor Nordstrom in 1971, shows us the worldwide distribution of tectonic coastal and shelf types, like we explained in the previous frame. In this map, we can highlight some of the collision coasts as in the Western, North, and South America. Some of the emerald trailing edge coasts as in the eastern South America, like the Brazilian coast. And finally, We can highlight also some of the marginal sea coasts, like the Chinese one. Second-order features classification from Inman and Nordstrom, 1971, considers the length and distribution of coasts subjected to process of wave erosion, wave deposition, river deposition, wind deposition, glaciated coasts, and biogenous coasts. The erosional effects can be A. Wave erosion, resulting sea cliffs, stacks, etc. B. Glacial erosion. C. River erosion at previous lower stand of sea. The depositional effects can be A. Wave deposition forming beaches, barriers, pits, etc. B. Glacial deposition modified by a wave action. C. River deposition and the formation of deltas. And D. Wind deposition and the formation of coastal dunes. The organic accretion can be A. Coral and algal reefs, and B. Mangroves, salt marshes, and etc. This table shows some of Inman and Nordstrom 1971 results in the statistical distribution of second-order features of the world's coastal zones. They classified the continents using their coastal lengths, indicating their percentage under wave erosion, wave deposition, river deposition, wind deposition, glaciated coasts, and biogenous coasts. Maybe it's important to highlight some of these results. The European and Asian coasts were unified, and 38% of their coasts were under wave erosion and 31.8% under glaciated conditions. The South American coasts were 48% under wave erosion, 20.8% under wave deposition, and 13.2% under river deposition environments. At the end of the table, the results for the world's coastlines. For all of them, 44.9% is under wave erosion, 11.7% under wave deposition, 3.2% under river depositional environments, 1.2% under wind deposition, and 36% are glaciated coasts. And biogenous organisms construct 3% of the world's coastlines. These results should be considered, obviously, under the perspective of science possibilities in the 1960s, but the use of this classification scheme was an interesting perspective on their epoch. Professor Inman and Professor Nordstrom in 1971 finally proposed a practical classification of the world's coast based on a synthesis of their first and second order model. There are 8 topics of classification of the world's coastline. The first one is the mountainous coast, where the shelf width is below 15 kilometers, coastal mountains are above 300 meters, and there are rocky cliffed shore zone with occasional pocket beaches. The second one are the narrow shelf hilly coasts, The shelf width is also below 50 kilometers. Coastal hills are below 300 meters, forming occasional headlands. The shore zone between the headlands usually contains beaches backed by cliffs or smaller hills. Occasional barrier lagoons or bay mouth barriers can also occur. The third one are the narrow shelf plains coast. The shelf width is also below 50 kilometers. Plains more elevated, shore zone deposits are less extensive, and there are occasional low sea cliffs and low headlands. The next one, number 4, are the wide shelf plains coast. The shelf width is above 15 kilometers. There are low-lying coastal plains bordered by a wide shore zone, usually including barrier beaches of some kind. They are typified by the Amero trailing edge coastline. The next one, number 5, are the wide shelf hilly coasts, where the shelf width is above 15 kilometers. Headlands are usually more widely separated. The shore zone may be wider, fewer cliffs, and may contain more barrier beaches. The wide shelf hilly coasts grade into plains coasts. The number 6 are deltaic coasts. Consists of the sediments deposited where a river or rivers enters the sea. Usually refers to low-lying coastal bulges that extend 50 kilometers or more along the coast and whose gross features are relatively unmodified by wave action. The next one, number 7, are the reef coasts, where the shore zone of the coast consists in parts of resistant material of organic origin. The reef may be fringing or it may be a barrier. The last one, number 8, are the glaciated coast. These coastal features are dominated by the erosional effects of glaciers, commonly has precipitous cliffs with deep embayments or fjords. In this map, the authors show the worldwide distribution of morphological coastal types, as we explained at the previous frames. Again, in the Western, North and South Americas, the distribution of coastal types are from the type of mountainous coast. In the Eastern South America, in the Brazilian coastline, there is the wide shelf hilly coast, and in Asia predominates the type of wide shelf hilly and deltaic coasts. It makes sense to examine the range of erosion and accretion coastal forms and consider classification schemes developed to organize coastal types into recognizable patterns and settings. So let's do it. Now let's start with erosional coastal features. Erosional coasts developed where active erosion by wave action occurs or where rivers or glaciers caused erosion when the sea level was lower than it presently is. For example, cliffs or rocky shores. Rock and cliff coasts are high and steep-faced coasts without a noticeable beach in front of it, and consisting of consolidated and unconsolidated materials of hereditary origin. A characteristic feature of many rocky coasts is the presence of a shore platform at the base of the cliff, being a relatively flat erosional rock bench with a marked drop at its seaward edge. On erosional coasts, bare rock generally is present because clastic products can be fully pulverized by grain interaction to silt particles, which are carried offshore. Rock and cliff coasts are typical along glaciated coasts. These coasts are characterized by diversity, such as rigid mountainous areas with exposed bedrock cliffs, headlands, embayments with pocket beaches, islands, drumlins, fjords, river fan deltas, and estuaries. Now, let's talk about some accretional coastal features. Sand, gravel, and cobbles, eroded from sea cliffs or delivered to the coast from rivers, are worked into a variety of accretional shoreline forms. Let's take a look. Sandy coasts are wave-dominated depositional coasts. The sand accumulations are deposited through process of wave action and wave-induced currents rather than through tide-induced or wind-induced currents. Generally, sandy coasts are open coasts exposed to wind-generated waves and may vary from flat, low-energy, straight coastal beach plains to steep, high-energy sediment-deficient, irregular bay headland coasts. Sand beaches may be bordered by cliffs, bluffs, and rocks. The most basic morphological elements are dunes, supratidal dunes, beaches, beach barriers, barrier spits, and barrier islands. Most of sandy beach plains have been formed a few thousand years ago, when sea level rise slowed it down. Mud coasts consist of predominantly inorganic sediment of media size less than 63 micron and are also known as chanier or chanier plain coasts. Chaniers are longshore ridges at the upper edge of the cross-shore muddy bed profile. The prevalence of marine process over fluvial process reduced supply is most favorable for chanier formation. The fine sediments predominantly originate from terrestrial sources, like soil erosion. The fine, muddy sediments, predominantly original from terrestrial sources, are mostly carried downstream by rivers. Example, Amazon River here in Brazil and Yangtze River in China. Typical characteristics of open muddy coasts are the presence of gentle shore face slopes, the brown colored coastal water, and the absence of large breaking waves. Incoming waves are attenuated by soft muds. The coastal zone is a broad term for the area influenced by the proximity to the coast. Onshore and offshore limits are imprecisely defined. On land, the limits may be a few hundred meters inland from a cliff top or several kilometers where there are extensive dunes or along tidal estuaries. The seaward limit may be the edge of the continental shelf, and it's usually at least several kilometers. The offshore zone is the portion of the profile where there is no significant transport of sediment by wave action. Landward boundary can be defined as the transition to water depths less than one half the wavelength of large storm waves. Note that the coastal engineers often define it as the outer limit of the breaker zone. The littoral zone is the portion of the coastal profile where sediment can be transported by wave action. The seaward limit is defined by the water depth at which significant sediment transport by wave action ceases, and the landward limit is the limit of normal wave action. The nearshore zone is the portion of the coastal profile extending from the limit of significant sediment transport by waves to the low tide line. The shore, or the beach, is the portion of the profile subject to wave action and which is exposed subaerially at least some of the time. Seaward limit is defined by the spring low tide line. Landward limit is defined by the limits of swash uprush during normal storms, often the vegetation line. The foreshore is the portion of the beach profile subject to wave action during non-storm conditions. Backshore is the portion of the beach profile subject to wave action only during storms. This is the beach for recreational purposes. The surf zone is the zone of broken waves extending from the breaker zone to the foreshore. Varies with beach slope and wave conditions and will only be present when waves break at some distance from the shore. The intertidal zone is the zone between high and low tidal waterline. The shoreline can be defined instantaneously as the intercept of the mean water level along the beach. It is often used as the swash limit or landward edge of the backshore. In this exercise, you are proposed to find some examples about Asian coast, maybe images or model schemes or graphs, etc., that includes information and coastal classification topics. Don't forget to write some explaining paragraph and indicate the reference. The information must be sent to my email address. Enough for today. See you soon. Take care and be safe.